Mistras, one source for asset protection solutions.
We will be using the following components during this video series: the pocketut itself, the R-Scan single encoded dry coupled scanner, and a carbon steel 4-step block, which is 1/2 inch in thickness on one end and 200 thousandths on the other. To assemble the R-Scan and the pocketut, we plug in the R-Scan cable to the back of the R-Scan, and on the top view of the pocketut we have our 12-volt adapter input. The transducers plug in to the TT input. The PR input, and the motion control. We press the power button, wait approximately 5 seconds. Windows CE will come up, followed by pocketut, and it opens up in the main menu of the instrument. Many of the pocketut functions are accessible via the touchscreen. Let's enter the A-Scan mode by tapping the A-Scan button to illustrate some of these functions. The top third of the screen allows us to adjust the gain of our signals. The middle of the screen allows us to adjust delay. The lower third of the screen allows us to adjust screen range. We can also adjust the gate by grabbing it and moving it up and down the screen. We can also adjust the length of the gate by grabbing an end. To ensure the accuracy of our calibration, we must first zero the transducer on the pocketut. To do so, we first tap our first icon here, which brings up our A-Scan graph. At this point, I'll go to auto calibration, and at this point I input 500 thousandths on my sound path for gate 1. I press the enter button on the keypad. Then I tap the calibrate button. Close out these menus. Then, if you notice at the bottom of the screen, our 0 point is located here. I touch the center of the screen and slide my delay to the far left-hand side of the screen. I can now adjust my screen range by touching the bottom of the screen and sliding to the right. In this exercise, to get an accurate thickness measurement, we must calibrate on the known material we're working with. For this, I will use my 4-step block, 500 thousandths on one end, 200 thousandths on the other end. To start this, I've got my A-Scan set properly with my gate. I tap the gate icon here to open my gate settings. Now I tap the THK, and now I tap auto calibration. I put my R scan on the block at the 500,000th side. I enter 500 thousandths. Then tap the time of flight button. I then move the R scan to the 200,000th side. Enter in 200 thousandths on my reference 2. I tap the time of flight button. Then I tap the calibrate button. And you will notice at the top of the screen, the 200 thousandths is shown. I slide up my block, and the 500 thousandths is shown. Now I can close the menus, and the unit is calibrated for this material. To ensure the accuracy of a scan, we must first note the length of the sample that we want to inspect. We can calculate this measurement by using the R scan itself. From the bottom icon menu of any scan mode, tap the motion control jog icon. Make sure the scanner is at one end of the sample to be scanned. Tap the 0 button. Then move the scanner along the sample. Notice the distance is displayed on the x-axis value here. The pocketut is one of the few handheld ultrasonic instruments that allows you to view an A scan, a B scan, and a C scan. Next, we will show you how to perform B and C scans. To perform a B scan, we must open the B scan window. We can do this from the main menu, or in this case, if we are already in the A scan mode, simply tap the B icon. Tap the settings icon here. This window contains 3 tabs. The Scan tab allows us to set our length, resolution, and, if using an automated scanner, the speed of the motor. In this case, we are using the R scan. We select the encoder option. In the Save tab, we can choose what type of data we wish to save, including time of flight, amplitude, and waveform data at high acquisition. The Display tab allows us to choose what type of data we want displayed. I will choose the time of flight profile. Now I'll close this window out. To begin, either tap the green light icon or press the Start button on the keypad. Move the scanner to the end of the sample and notice the B scan is displayed live. When the scan is complete, we can tap the measurement icon here to display the A scan graph option. We can see a side-by-side view of both the A and B scan graphs. Tapping a point on the B scan shows the corresponding A scan for that point. The distance traveled, amplitude, and thickness of each point is displayed on the top of the screen. As with the B scan, the C scan window can be opened from the main menu or in the A scan mode by tapping the C icon. Tap the settings icon to open the C scan settings window. It contains 3 tabs. First is our scan axis that allows us to set up our start point, which is 0, our length of 7 inches, resolution of 50 thousandths, and again a speed if I were using an automated scanner. The index axis tab allows me to again set up a start point, again at 0, length of 3 inches, resolution in this case of 250 thousandths, and again our automated scan speed. The Save tab allows me to save same data, time of flight, amplitude, waveform, and acquire data at a high rate of speed. I close this menu out, and as before, either tap the green light icon to start my scan, or by pressing the start button on the keypad. Unlike the B scan, the C scan requires multiple passes of data. The scan will automatically stop when it has reached the limit of its envelope, which we previously set of 7 by 3 inches. When the scan is complete, we can tap the measurement icon here, and again by tapping the A scan graph option, we can see a side-by-side view of the A scan and the C scan. Tapping a point on the C scan shows its corresponding A scan, the distance traveled of both X and Y, and the thickness, which is displayed at the top of the screen. Now that we have our data stored in our pocketut, we can do further analysis on your computer. To open up the program, we double-click the UTWin icon, which then opens up our program to the screen that looks like this. At this point, we take our compact flash card and plug it into our compact flash reader to view the data. I go up to the top of the screen and click on Replay. Since I am opening C-scan data, I will come down and highlight Open C-scan data. At this point, the computer asks me where do I want that data to come from. I click up, come down to my removable disk, and now here's all of my data. I go to the particular piece of data that I want to look at, and I double click. It now opens up a C-scan screen. At this point, I can move this around by right-clicking and putting my Windows titles. Now I can move and resize the C-scan. At the bottom of the C-scan, it's showing this is an amplitude scan. This particular C-scan that I want to view is a thickness or time of flight. I click on the amplitude and click on time of flight. And now we can see the areas of corrosion from the scan I took from the pocketut. At this point, I can open up other screens. If I want to view the A scan, I can right-click and open a plot graph. Now it opens up my A scan graph, and I can again resize this graph. And as I put my cursor across my C scan, it shows the corresponding A scan that goes along with that reading. I can also open up a B scan, move my cursor off of the C scan, right-click my mouse, open up a new image graph, and go down to my lowercase B scan image and click. Down at the bottom you can see this is also an amplitude scan. I want to view the time of flight. And now I have to do one more step. Right-click on the graph, go up to Graph Setup, and push Fit View, and close this out. Now I can resize my B scan. And now any line of data that I'm looking at that my cursor is on going in this direction, I can now view the B scan on the bottom. One more piece of data is I can set up a data table, which will give me a list of thickness readings for known points on the C-scan. Right-click again, a new table, C-scan data table. Again, this data table is in amplitude. I want to change it to time of flight. So now I'm getting thickness data. So now anywhere that my cursor is placed, you will notice down at the bottom part of the screen, the green number is where the cursor is, blue is the thickest area, red is going to be the thinnest area. And you notice how that changes over an area of corrosion and an area of good material. One final step, what do I do with this data? I can now take all of the data from my C-scan. I click on the C-scan. I go up to the Excel icon and click it. What this will allow me to do is open up all this data in a color-coded Excel spreadsheet. I choose C-scan data. I also choose Set Cell Background Color. I now export this to Excel. Now Excel opens up a color-coded spreadsheet that gives all of my data. This can then be printed out to go along with your C-scan data for a full document. Now that I have the screen set up the way I want it for all presentations, I can save this as a project. I go up to File, go down to Save Project As, and I name the file. I'm going to store this project on my desktop. And let's name this project. I hit save. And now every time I open up this program and open up a C-scan, it will open up the C-scan map here, A-scan data, B-scan, and the data table.